Okay. Right. So up until now, we've just been talking about visible light. Okay, you've been doing lots of experiments with visible lights, reflection, refraction, total internal reflection. So we're going to sort of go beyond the visible light. So the visible light is part of a spectrum that we can see, but actually beyond that visible light, there's a whole spectrum of different sort of radiations that have similarities to light, but also are quite different as well. So we've done the experiment where you found a rainbow by shining light through a prism or through a triangular glass block. And we know that happens because of refraction, okay? Because each different color of light gets refracted slightly differently, okay? So that's why they start spreading out. So they get bent slightly differently, okay? And the reason that they get refracted slightly differently, slightly different angles, is because they're different. They have slightly different frequencies and different wavelengths, okay? So each color has a different frequency and a different wavelength. But that's only part of that spectrum. If you took a phototransistor, so that's just basically something that picks radiation up. So light is a radiation. I don't mean like poisonous radiation or anything. Okay, and if you put it at either side and beyond that rainbow that was created, you would pick up more radiation, and that's because there's that spectrum of radiation on either side. Okay, so a phototransistor can be used to detect radiation passing from a light bulb through a prism that our eyes cannot see. So the phototransistor is capable of detecting, this type of radiation. So if we go past the red part, next to the red part, we have something called infrared radiation. Okay, so you've probably all heard of, it's infra, not infra, red radiation. Okay. Infrared radiation has a longer wavelength than visible light. We can't see it with our eyes, our normal eyes, but you've probably seen like heat cameras and things like that, infrared goggles, night vision, things like that. They pick up infrared radiation. So we all give off infrared radiation because it's usually heat. The radiation that's given off as heat is infrared radiation. Okay, so if you can't see, obviously, this radiation being emitted from everybody, maybe not the people at the back who are freezing cold, they might not be emitting much heat at the moment, but you could detect it if you had special equipment. Okay, and as well as that, on the other side, so you know the rainbow is red, orange, yellow, green, blue, indigo, violet. On the other side, there's ultraviolets, which you've also probably heard of before. Yeah, so ultraviolet is like UV, so there's lots of different uses for ultraviolet. You can detect ultraviolet using special detectors, but you can't see it with your eyes. And beyond infrared and beyond ultraviolet, there's extra, and Daniel's already noticed up there, it's called the electromagnetic spectrum. So the back sort of wall over there, that's sort of like you can briefly look at that if you want to see which one's which. So on the next page, we're going to talk about this. So you'll see there, we've got radio waves, microwaves, infrared radiation. Then you've got your visible light, so red, orange, yellow, green, blue, indigo, violet. Then you've got ultraviolets. Then you've got X-rays. And then you've got gamma rays. Okay? So the differences between these are all about the different frequencies and the different wavelengths, and therefore if you have a higher frequency, you have a higher energy associated with them. Okay, so they span different wavelengths, different frequencies. The one thing they do have in common is they all travel at the same speed, because remember we've talked a little bit about this before. Microwaves travel at the speed of light. They all travel at the speed of light. Okay, so visible light is only one small part of a set of transverse waves known as the electromagnetic spectrum. Okay, the visible light is the only part that the human eye can detect from about wavelength of 4 times 10 to the minus 7 meters, which is violet, to about 7 times 10 to the minus 7 meters. You don't need to memorize the numbers, but you do need to know the order. Okay. So different parts of the electromagnetic spectrum have different properties since they have different wavelengths and frequencies. All of the waves in the electromagnetic spectrum travel at the same speed through a vacuum and through air, which is the speed of light, 3 times 10 to the 8 meters per second. You do need to know that, okay? Because quite often you'll think they haven't given you enough information, but you can probably take away that it's traveling at the speed of light. So here is a little diagram of the electromagnetic spectrum. So you can see here, we've got increasing wavelength. So these ones have got the longest wavelength. This one's got the shortest wavelength. Okay. Frequency wavelength goes the opposite way. So this one's got the highest frequency, and these ones have got the lowest frequency. You can see visible light sort of in the middle there. Okay. And the highest frequency means higher energy as well. So I'll just put that here as well. Highest energy. So gamma rays, which you probably associate with sort of like, Hulk experiments and things like that. Gamma rays are probably the most dangerous because they're the highest energy, so they can do the most damage. Okay, and we already know a little bit about gamma rays, and we know that they're quite damaging. They're quite penetrating as well. They can get quite far. Okay, you will see that some parts of them overlap. Okay, and that's because it's sometimes the source of the waves which decide what we call them, and sometimes it's the energy we supply to produce them. So, for example, an X-ray machine could produce X-rays of a very short wavelength, which have the same wavelength as gamma rays from a radioactive source, but they're still called X-rays because of the way they are produced. Okay, so there is some overlap in them, but we definitely have an order. So we've got gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, radio, and TV waves. Okay, and in terms of the visible light, violet is next to ultraviolet and red is next to infrared. So that's how you remember that. And then obviously the colours in between as well. Okay. And you do, I'm afraid, need to know this table because they do quite like to ask you examples of a source and examples of a detector of types of radiation. So you've got a table there that gives you gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, and radio waves, examples of sources, and examples of detectors. So you do need to know those. So that's quite in a sort of like handy table for you. I'm afraid it's kind of one of those things you just need to learn off by heart. But I do have a nice way for you to remember the electromagnetic spectrum. It is a song, yeah. So normally, in normal times, I would be really encouraging for you to sing along with it, but obviously you can't belt it out at the moment because of coronavirus. So I'm going to play it, and by all means, boogie away with it and just talk through it because it will be stuck in your head by the end of it. It is the most cheesy song ever, but it just you will never forget the electromagnetic spectrum. So right, I'm going to play it for you, and now. Right, as I said, don't expect high quality. But expect something right.
Electromagnetic spectrum is just a name for a range of radiation that tell you what they are. Radio waves, microwaves, infrared radiation, ultraviolet, X-rays, gamma rays. From TV stations to your living room, that is the work of radio waves. Heating food in just seconds, microwaves do that. Heat treatment for illness, take pictures in the dark. They are even in your remote control. Infrared radiation, the electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, ultraviolet, X-rays, gamma rays, red, orange, yellow, green, blue, indigo, violet. That is the only part of the spectrum that can be seen by us. The suntan on your skin kill bacteria and viruses used to detect forgery.